So here's the requirement to solve simultaneously for W and Z. This is the form of our final answer. W equals to something, Z equals to something. Okay, before we go into this question, I want to make the point that in using simultaneous equations, x and y must be involved in the equations given. Take for instance in this case. Now on the right hand side you have a case of 2 times 2 plus 5 times 2, and on the left hand side you have 2 plus 6 times 2. While the both left and right hand side would come up to a 14, you are not supposed to use comparing the parts to in this case over here, because if you do, take for instance, then you must agree that 2 equates to 1 when 5 equals to 6. But how can this be correct? So comparing of parts works only when both variables are involved in the equations given. To make things clearer, I have exchanged all w's with x's and all z's with y's. So now I'm working with these two equations, ix plus 3y equals to 2 plus 4i, and x plus 1 minus I y equals to 2 minus I. Solving them simultaneously, I should be able to get to y equals to minus 1 minus 2i over I minus 2. And so using my calculator, I know that my answer equates to an I. So if my my y equals to an I, it means that my z equals to an I. Substituting this into equation 5, I will be able to find that my x, which is really a w, equates to 1 minus 2i. This is what happens if you try to use comparing the parts to work this out. You are going to end up with a 2y equating a 1 to a 1 and a minus y equating to a minus 2i. Solving it, you would actually yield you two answers for y. Y cannot be 1 over 2 and minus 2 at the same time because we are not dealing with a quadratic equation.